So in number 8, you're given the graph of a line in the xy plane, and your job is just to find an equation for it. So in any problem that asks you to find an equation for a line, where should you start? Where do you want to start? The x's, and what do you do with the x's? Which x's?
3 and 5.
3 and 5. Well, 3 and 5 are not both x's here, but they are both the coordinates of the point that we see on the right. So it's probably a good idea to start by labeling the points, if that's the name of the game. Let's make sure that we know what the coordinates of these 2 points are. So 3, 5 is the point on the right. What's the point on the left?
-2, 3.
-2, 3. Okay. So there are the coordinates of these 2 points. Now, what template can we always use to write the equation of a line?
mx plus b.
Yeah. So it's a good idea. Keep the goal in mind, right? Begin with the end in mind. Isn't that, what is that? Is that one of the 7 habits of highly successful people or something? I don't know. Begin with the end in mind is one of those classic tropes that if you can manage to do it, then you won't get led astray. So this is what we're shooting for, is this template. And in this template, we just have to supply values for m and b. And if we supply those values, then we will have the equation that we're looking for. So we just have to find them. We have to find 2 numbers, m and b. What role does m play here? What do we call m? The slope. So if we find the slope, then we know that's what's going to go in that little slot. What about b? The y-intercept. So if we happen to know the y-intercept, then we'll stuff it into that slot, and we'll be done. Which one do you want to find first? Yeah, let's make the slope your number 1 priority in these problems. Find that slope, because that's something you can directly compute just from the coordinates of the 2 points that you're given. The y-intercept is something we'll have to compute secondarily. So we'll worry about that one after we've worried about the slope. So how am I going to find the slope of this line? And how'd you get that? All right, so the slope is what we see. Yeah, rise over run. And rise is another name for the difference in y values. In other words, y2 minus y1. The second y coordinate minus the first y coordinate. And the run is another name for the difference in x values. The second x value minus the first x value. So, looking back at our points, let's label them. Here's the first point, x1, comma y1. Here's the second point, x2, comma y2. It doesn't matter, as long as you're consistent, which one is which. Because if I flip-flop the 2 terms in the numerator of this denominator and in the denominator of this fraction, then the top is going to change sign, the bottom is going to change sign, and those 2 sign changes are going to cancel one another out. So it doesn't matter which of the 2 you label as the first point and which you label as the second point, as long as the x and y that correspond to the same point are located above one another in this fraction. And the other common mistake that people make is the y's are on top. If you put the x's on top, you're going to get the reciprocal of the fraction you're looking for. All right, so if I labeled it this way, then the point 3 comma 5 is going to become, in my fraction, it's going to look more like this. 3 comma 5. Right? So the 2 coordinates of that second point I've put into the fraction, up and down. And then negative 2 comma 3 will become, in my fraction, negative 2, 3. And my job is then to subtract those from one another. And this is what Dat was saying a minute ago. 5 minus 3 on top gives me a 2. 3 minus negative 2, what is that? 5. It's the same as 3 plus positive 2. So that's the slope of my line. And if we sketch that in, that 2 is this difference over here. Right? It's this length, if you like, plus 2. And the 3 minus negative 2 is the change in the x values, which is this distance over here plus 5. Okay. So that's where those 2 and 5 are coming from. Right, is the number of grid squares that we're counting between these 2 points in the horizontal and the vertical directions. So now that we know the slope is 2/5.
You almost kind of luck out. When you're given a graph, it's almost like you kind of luck out. You really don't.
So we know the slope is 2/5. Now we just have the job of finding the y-intercept. What does that entail? Now that we know the slope, how do we find the y-intercept?
Oh, 0, 1, 2. You have x equals 0, and then it'll be 0 times 2/5, and then 1 times 2/5, and then 2 times 2/5.
Okay, so the y-intercept is the y value that this graph will have when the x value is equal to 0. The problem is the information that we're given on this graph doesn't tell us anything about what happens when x is equal to 0. What x values do we know about?
2, 3, and 5.
Actually, just -2
Oh,
and
just
3,
x's.
just the x's, right? So the only x's that we know anything about are this x right here and that x right there. So these are the candidates that we can use to help determine the value for this y-intercept. Let's suppose that we choose x to be 3. If x is equal to 3, then what do we, yeah, if x is 3, then y has to be 5, because the point 3,5 is a part of this line. So that means that if I put 3 in for x and 5 in for y in this equation, that I'm going to get a true statement. And that true statement, let's put the 5 in for the y and the 3 in for the x. Y equals, and our slope was 2/5. And our y-intercept is this thing that we don't know. But putting in specific values for x and y give us a new equation that goes from having 3 unknowns in it down to having only 1 unknown in it, namely b. And as soon as I have an equation with only 1 unknown in it, I can solve that equation to determine the value of that unknown. In other words, now I can find out b. How do I do it? How do I solve this equation?
Find out what 2/5 times 3 is.
2/5 times 3. So make 3 into a fraction, 3 over 1. Multiply across, what do you get?
6/5.
6/5. 6 on top, 5 on the bottom. So I'll still have 6/5 plus b. The left-hand side of the equation is still 5.
So you did subtract 6/5.
Subtract 6/5 from 5. I'm just going to take a shortcut here and do this. Okay. So to subtract 6/5 from 5, we'll get a common denominator. 5 over 1 is the same as 25 over 5. And what's 25/5 minus 6/5?
19/5.
Yeah. So B, our y-intercept, is 19/5.
Question.
Yeah.
Why did you choose x equals 3 and y equals 5 again?
And if this were an open response question, a lot of times people will forget to then close the loop by actually putting that y-intercept into the template, and then your final answer is that equation. Y equals 2/5 x plus 19/5, which is also choice A, just like the other 2 questions that we talked about, ironically enough.